Okay, good morning guys. Today we will discuss the new concept that is what electron gain enthalpy. Okay, electron gain enthalpy. Okay, yeah guys. Yesterday we discussed about ionization enthalpy and its variation along the period and down the loop. And today we will discuss this electron gain enthalpy. Okay guys. Here this is a quantitative measurement of an energy liberated by an atom when you guys were adding an extra electron to it. Okay. For example, here this is what a neutral gaseous atom. I will consider this as an X. That when you guys were adding an electron to it, when we are adding an electron to this neutral gaseous atom, this will be converted to a negatively charged ion, right? This will be converted to a negatively charged ion. We call this ions as called as anions, right? We call this as an anions. Okay. For this reaction, what would be the change in an enthalpy? What would be the change in an enthalpy? Is called as what? Electron gain enthalpy. Okay. For this simple reaction, we are adding electron to a neutral gaseous atom, and this neutral gaseous atom will be converted to a negatively charged ion, and we call this ion as an anion. Okay. For this conversion, what would be the change in the enthalpy for this reaction? Is called as what? Electron gain enthalpy. Okay. Based on the nature of the element, your electron gain enthalpy is an endothermic or an exothermic. Okay, or exothermic. Okay, here what do you mean by this endothermic and exothermic reaction? That is what you guys have to know. Here endothermic reaction means for a reaction we are supplying some amount of energy. That means this kind of reactions will need some energy. Okay. Then these were called as what? An endothermic reactions. That means we are supplying some heat energy for this reactions means then this is called as what? Endothermic reactions. If the reaction is liberating some kind of heat energy or any kind of energies means then these were called as exothermic reactions. Okay. Liberation of energy, absorption of energy. For a reaction, that reaction is absorbing energy means we call that kind of the reaction as an endothermic reaction. If for the reactions which are liberating some amount of energy means we call those reactions as an exothermic reactions. Okay. Here, based on the nature of this element, your electron gain enthalpy. It may be an endothermic reaction or it may be an exothermic reaction. Most of the elements in your periodic table, they will add some extra electrons by liberating the energy. That means the reactions will be an exothermic in nature. That means when you add an electron to a neutral gaseous atom, this reactions involves an liberation of some amount of energy. So, most of your periodic table elements will liberate energy when you add an electron to it. Okay. Only the noble gases, when you consider the noble gases, here the noble gases, we are adding an electron to it means this will undergo an endothermic reactions. That means what? We has to give some amount of energy for the addition of electron to the noble gases. Okay, be careful here. This is what a noble gas series will need some amount of energy to add an extra electron to it. Whereas other elements of your periodic table will liberate some amount of energy when you add an electron to it. Okay, be careful with this noble gas. Noble gas will need some amount of energy for the addition of extra electron to it. Okay. Here, finally, what do you mean by this electron gain enthalpy? Electron gain enthalpy is nothing but what? Energy change during the process. When we are adding an extra electron to a neutral gaseous atom. Energy change during the process of an and adding an extra electron to a neutral gaseous atom. This is called as what? An electron gain enthalpy. Okay, it may be positive or it may be negative. Okay, yeah guys, how would you assign the signs for exothermic and endothermic reactions? I told you that most of the periodic table elements will liberate energy when you add an extra electron. If liberation of energy is taking place in the process, then we will designate that with a negative sign. With a negative sign. Whereas endothermic reactions is there. That means we are supplying an energy for the conversion of X to X minus, or an adding of electron to a neutral gaseous atom. Then endothermic is there means, that means we are supplying some amount of energy means we will designate the sign with positive. Okay, here endothermic reactions we will take the sign as positive, whereas for exothermic reaction we will take the sign as negative. Okay, here in your periodic table guys, here the halogen series will have a more negative electron gain enthalpy, because here your halogen series will have an outer electronic configuration of ns2 and np5, right? ns2 and np5. If you add an extra electron to it, if we are adding an extra electron to your halogen series, then the electronic configuration changes from ns to np5 to ns to np6. And you guys know there was a noble gas configuration, and this configuration is highly stable. To achieve this stability, the halogen series elements will liberate more amount of energy. So halogens will have a more negative electron gain enthalpy. That means those elements were liberating lot of energy when the electron is added to those elements. Okay. Then you have noble gases here, these were what? An endothermic reactions. That means we have to pass some energy to add an extra electron for this. Because of what? Because it is already having a filled configuration ns2 and np6, right? ns2 and np6 in its outer electronic configurations. Okay. We are adding an extra electron to this one means, again the principal quantum number increases, so that it will achieve an configurations with very instability. Okay, here the next configuration becomes what? Next configuration becomes your s block elements. That means and group number 1 element, right? If you add one more electrons to this means ns2 np6, and the next principal quantum number will come. I will represent this as n plus 1 s1. Okay, this is what the configuration when you guys were adding an extra electron for this noble gases. When this configuration is there, this is an highly unstable configuration, and so that your noble gases will lose its stability. For this reason, this noble gases does not want to take an extra electron, so that we need an amount of energy supply. We have to supply some amount of energy to add an extra electron for this noble gases. Okay, did you got this? If this noble gases will add an extra electron means its configuration becomes an n plus 1 s1 series, and this is what an highly unstable configuration, so that noble gases does not wants to take one more extra electron to it. So if you want to add an extra electron for noble gases, we need to supply some amount of energy. Okay, this is what the reason. Their noble gases is an endothermic reactions, whereas other element your electron adding will be an exothermic reactions. Okay, here next comes the variations of this electron gain enthalpy along the period and down the group. Okay, here guys, the similarities is not like your ionization enthalpy. There, the symmetric nature is there. Here, along the period, ionization enthalpy increases. Down the group, ionization enthalpy decreases. Those kind of the similarities we can't observe in this electron gain enthalpy. Okay, your electron gain enthalpy, guys, that means you already know that amount of energy will be liberated when an electron is added to a neutral gaseous atom. Okay, here in the case of noble gases, energy we have to supply to add extra electron for this noble gases. Okay, here again the trends we are discussing out according to the periodic table. That means an increase in the period and decrease in the group. That means what? Down the group and along the period. That means here your electron gain enthalpy will increases along the period and decreases down the group. Okay, again the periodic trend for this electron gain enthalpy is what? Which increases along the period and down the group it will decreases. Okay, down the group electron gain enthalpy decreases. Okay, periodic trends for your electron gain enthalpy is what? Along the period it will increases, down the group it will decreases. Okay, because guys you already know that when we are moving along the period, then we know that effective nuclear charge of an atom goes on increasing when we move along the period. When we move along the period, effective nuclear charge will increase us. That means what? If effective nuclear charge increasing means in an atom, positively charged nucleus and negatively charged electrons, attractive force between these two were increasing out, right? If effective nuclear charge is increasing means positive capacity holding to a negatively charged electrons will increase. That means what? Attractive force between your nucleus and an electrons, outer electrons will increase. So that we can easily add one more extra electrons for this, one more extra electrons for these elements when we move along the period. Because of the increase in an effective nuclear charge, the electron gain enthalpy also increases. That means amount of energy liberated will also increases. Okay, whereas if you move down the group, yeah guys, as down the group, you know that effective nuclear charge will decrease. That means what? The attractive force between your positively charged proton and a negatively charged outer electrons will decrease. So that the electron gain enthalpy, amount of liberation of energy, what we call, that will decreases down the group because of this effective nuclear charge. Effective nuclear charge decreases down the group, so that attractive force between your nucleus and that of the outer electrons will decrease, so that the electron gain enthalpy will also decreases. That means energy liberated during an addition of electron down the group will decreases because of the size of the atom increases and electron nuclear charge will decreases. Okay, effective nuclear charge decreasing out means there is a less amount of attractive force. If amount of attractive force is less means energy liberated during the process of conversion of an neutral atom to an anion will be less, so that the down the group electron gain enthalpy decreases. And one more thing guys, you should observe here, they will ask a 2 marks question, give reason for these questions. That is what, you know that as I told, along the period electron gain enthalpy increases, down the group electron gain enthalpy decreases. Okay, here for an element of oxygen and fluorine, here this is what, group number 17, and this one is what, group number 16. Okay, here for an fluorine, the succeeding element is what, fluorine, whereas oxygen, here this is what, and sulfur. Okay, I told you as we move down the group, the electron gain enthalpy decreases. But in the case of oxygen and fluorine, sulfur and chlorine will have an highest electron gain enthalpy compared to your oxygen and fluorine in the corresponding series. Okay, yeah. Sulfur will have highest electron gain enthalpy compared to oxygen, and chlorine will have an highest electron gain enthalpy compared to fluorine. As we move down the group, according to a regular trend, electron gain enthalpy should decreases, but in this series, we will find an increase in an electron gain enthalpy for your sulfur and chlorine compared to oxygen and fluorine. The reason is you know that oxygen and fluorines were the smallest atoms, right? Oxygen compared to sulfur, this is what a smallest atom, and fluorine compared to chlorine, this is also a smallest atom. So here guys, oxygen electronic configuration is good. This will have 1s2, 2s2 and 2p4. Whereas your fluorine, that will have an electronic configuration 1s2, 2s2 and 2p5. Okay, here guys, there were 9 electrons in fluorine with a smaller size, and you know that along the period size of the atom decreases, so that in a small size we will have a large number of electrons. For the fluorine it is good, and it consists of 9 electrons, and you also know that along the period size of the atom decreases. That means fluorine will have a smallest size and with a more number of electrons, and those electrons were very near to your nucleus. And if you are adding a negatively charged extra electron to this atom, then the previously existing electrons will repel these electrons, upcoming electrons. Okay, here because of the smallest size of the fluorine and the electron present in these clouds of fluorine atom will repel the upcoming electron, so that the fluorine will have an lesser electron gain enthalpy compared to an chlorine. Chlorine here its atomic number is 17, and it will have an configuration of 3s2 and 3p5 at its outer electronic configuration. That means at its outer orbital it will have 3s2 and 3p5 configuration. That means from the nucleus these orbitals are far away, so that there is a less amount of repulsion for the upcoming extra electrons. Okay, this upcoming extra electrons will feel some less repulsion because of the size of the orbital is increasing out when we move from fluorine to chlorine, so that the electron gain enthalpy for chlorine is more compared to fluorine. This is what the reason. When you consider oxygen will also have 8 electron, and its outer configuration is what 2p2 and 2p4. Sorry, 2s2 and 2p4. Okay, here also, whereas in your sulfur we will have an 16 number of electrons, and here the configuration, outer electronic configuration 3s2 and 3p4. Again, the size of the atoms will increase from oxygen to sulfur, so that the repulsions between the electrons will be less. So electron gain enthalpy for the sulfur is more compared to an oxygen. Here oxygen, this is having a smallest size with a more number of electrons. 8 electrons were there, so the repulsions will be more. This is what a major reason why the chlorine will have a highest electron gain enthalpy compared to fluorine, and why the sulfur will have a highest electron gain enthalpy compared to oxygen. This is what a complete picture of electron gain enthalpy. Okay.